So we've talked about forces and this whole idea that forces change the motion of a body if they're unbalanced. And when we said about changing motion, we mean it's changing the speed or maybe changing the direction or maybe both. And if there's a change of speed and direction, that means there's a change in velocity. And a change in velocity is an acceleration. And remember, in physics, an acceleration can be speeding up or slowing down. In the real world, people only talk about acceleration as speeding up. So if I were to look at this glass here, and at the moment there's no change in motion, and hence there's no forces exerted on it, which are resultant forces. Obviously, there's a weight going down, and there's an opposite force supporting it from the tabletop here. But if I actually turn the glass on its side and I push it, a very, very small force creates a big change in its motion. And we've talked about this before, the fact there's a relationship between the force, the mass of the object, and the acceleration. So the bigger the force, the bigger the acceleration for a certain mass. If I push something which is very light, there's a much bigger change in motion of that than there is if I push something which is very heavy. If I exert a very big force, I have a bigger change in motion to the body than from a smaller force. And force is mass times acceleration. So what would happen then if I actually put the same force I exerted on it before and pushed it across when it was rolling on it now, and it's not moving? So I am exerting a force on it, the same force I exerted on before, but now there's no change in motion. And the question is, what's stopping it moving? And the answer, of course, is friction. Friction, in this case, is between two solid objects. Now, some people think friction only occurs between solid objects, but not. It's also about drag, it's all about fluids, which are liquids and gases, which we'll look at later. So at the moment, when I'm pushing it, there's no change in its motion, and that we call the frictional forces in a state of grip. I can increase my force I'm exerting, the contact force, the distortion force, to the point where it goes from a state of grip, where it's not moving, to a point of slip. And once it's gone past slip, we now move into what we call drag. As I'm pushing it across here, I'm having to do work against the frictional force. If it's moving at a constant velocity, then what I can say is the frictional force going this way is exactly the same as the distortion force I'm exerted going the other way. So how might I increase friction? Well, sometimes we want friction, so if I use some sandpaper here, much rougher surface, and I put the glass on the rougher surface, then I need to create a much bigger force until it goes beyond grip into the state of slip, and then into drag. So I'm now doing much more work against friction than I was before, because I've got a much rougher surface. So that's kind of how friction works between solid objects. If I wanted to reduce the frictional force, well, what I could do there, I could use lubricants, I could oil the surface, I could smooth the surface down, I could smooth both surfaces, and that would actually reduce the amount of work I'm having to do against friction in order to move it a distance.